one of the trendiest topics on internet right now. Yes, generative AI. From LinkedIn posts to Instagram reels to AI communities, everyone's talking about it. But guess what? By the end of this video, you'll actually understand it. So, this is the only video you need on the entire internet to understand what generative AI is and how it works. I'll cover everything and explain it in a way that even if you're a complete beginner or someone who's never touched AI before, you'll still get it. So, what are we covering today? First, we'll be covering Introduction to Generative AI, moving on to its types, GANs, VAEs, diffusion models, then application to Gen AI in real life, popular tools that are around us and you can use right now. And finally, how to build your own text to image generative AI model, how to give it a better instructions, aka prompt engineering, and how to fine tune existing AI models for your custom needs. So let's get started. Alright, what even is generative AI? Well, imagine you have a massive dataset, like tons of information, articles, images, videos, everything. Now, using math and algorithms, this data is processed, calculated, and learned through something called training. It knows what makes sense and what doesn't, and how to create new things based on what it learned. This model can now generate text documents, write stories, summarize articles, answer your questions, basically anything with the text. And not just with the text, it can also generate images, videos, and even audio. Yep, the AI generated videos you see on Instagram are all built using generative AI models. Pretty simple to understand, right? This is the basic workflow that every generative AI model follows. But now comes the real question. What happens inside these steps? How do these models actually get this smart? Let's dive. Companies like OpenAI, Google, Meta have spent years collecting gigantic datasets. And here's the simple rule. The more diverse and bigger your dataset, the smarter your AI model becomes. They scrape text, videos, images, audios, articles, blogs, books, YouTube transcripts, and even more reports. Basically, every piece of information humans have created. Next, they convert all this information into a format that computers can understand, because at the end of the day, everything is just zeros and ones for a machine. So they convert text, images, videos into data structures, whether it's a plain text, JSON, pixel array, or numerical matrices using programming languages like Python and C++. Now, then comes the most important part, training the model. They use advanced algorithms and AI libraries to feed the data into a powerful GPU, which run calculations, make predictions, learn patterns, and improve accuracy over time. Think of it like this. You're teaching a kid how to recognize fruits, and you show him thousands of images of apples, bananas, and mangoes. Tell him the names and test him again and again and again until he stops calling mango a banana. In AI, it's pretty much simple. And same, we show the AI model millions of examples of how images, text, videos, and it slowly starts recognizing the patterns. Which words are often used together, what colors usually make up a cat's face, how a news article is structured. During the training, the AI keeps making the predictions, gets corrected when it's wrong, and updates itself. This process repeats thousands or even millions of times until the AI becomes smart enough to generate its own content. Types of generative AI models. And the first one we have GANs, Generative Adversarial Networks. A GAN is made up of two AI models. One is generator and the other is discriminator. This constant battle makes both of them better, and that's how you get AI generated deepfakes, art, and even fake Drake songs. Let's say you have a generator AI whose job is to create fake images, let's say fake paintings. Then you have a discriminator AI, whose job is to figure out if the image is real or fake. In the beginning, the generator is bad, like really bad. It makes weird, blurry images. The discriminator easily catches it and says it's fake. But here's the fun part. Every time the discriminator catches the generator learns from his mistake and tries to improve. At the same time, the discriminator also improves, becoming smarter at catching fake images. And after hundreds of rounds of training, the generator becomes so good that it starts making images so realistic even discriminator cannot tell the difference. Next we have VAEs, Variational Autoencoders. Fancy name, simple idea. Think of it like your phone's photo compressor. It takes data like images or text, compresses it into a smaller, simpler version called a latent space, and then reconstructs it back into smaller, similar to the original. It's a bit blurrier than GANs but useful for generating images, sounds and data with built-in structure. For example, if you give it a photo of a girl, it shrinks all the important information about that girl into a compressed form and later reconstructs it back into a new, similar looking girl. You may have seen this type of images where one person draws a pixelated number and the computer finds it out. Yes, that include VAEs. Diffusion models. These are behind Stable Diffusion, DALL 3, Midjourney, and those AI art posts you see online. They work by starting with complete random noise, like literal static, and slowly removing the noise step by step, turning it into a clean image. Imagine you have a super clear image of a cat. Now what if you started adding random noise on top of it, slowly destroying it until it turns into pure static, like a bad TV channel from 90s. That's forward diffusion, where we gradually add noise and mess up the image. The AI learns how to reverse this process. It takes the noisy, static image and step by step removes noise from it until it finally reconstructs a clear, clean, new image. The reason diffusion models are killing it right now is because they generate super high quality, detailed, creative images, better than most GANs and VAEs. Application of generative AI. First up, we have text generation. Models like ChatGPT, Gemini, Claude, they can write poems, essays, emails, tweets, Instagram captions, literally anything you want. People are even using it for their exams and corporate mails, which is both hilarious and mildly dangerous. Image generation. Tools like DALL can turn your text prompts into stunning high quality AI art. From memes to marketing posters, nowadays most are generated by these. Video generations. This one's the future. AI from video generation is what projects like Sora by OpenAI can generate full video clips from a text prompt. Audio generation. AI is generating music, sound effects, and even voice clones. There are tools like Aiva that can clone your voice, make AI podcast or auto-compose it lo-fi beats for your study sessions. AI coding assistants. If you're a developer, this one's a blessing. Tools like GitHub Copilot, Blackbox, Claude can generate code for you, suggest functions, or even write entire programs based on comments. It's like having a free intern who never takes a coffee break. AI-powered design and marketing. Marketers using AI tools like Canva's Magic Design or Copy.ai to generate ad banners, logos, captions, and scripts within seconds. What used to take hours now only take 30 seconds. Create our own text to image generator using the same technology and tools and generative AI that we have discussed currently. So you can see this code over here on my screen, and first of all, these are all the modules and packages that are required to make this code run. So after that we have this opt c equals to 4 and opt f equals to 8. So what are these? C is actually the number of latent channels, which is how the model internally stores compressed image data, like hidden layers. Stable diffusion, which the model that we discussed uses only 4 channels, while F, that downsampling factor, yes, this decides by how much your image is shrunk before being processed. Stable diffusions typically shrinks it 8 times before working on it, because working on a small version is faster than it expands it back later. So these are some constants we have to define before putting our image into the stable diffusion model. Then we have a function for color correction. So what happens is, when an image looks weird, when colors are messed up during an AI generation, so what we do is we set up a color correction function. It converts your image to something called the lab color space, where lightness and color info are separated, because it's much easier to adjust brightness and color separately in lab space than in regular RGB. Okay, so then this is the function for applying the color correction. Once we have set up that function, we now match the color tones of our AI generated image with the target image using something called histogram matching. You can see over here I have made an array of functions that is calling this histogram. See over here, it's a class basically. So then we adjust the colors so your image doesn't look weird or dull, and it makes sure it stays natural. And we blend the brightness separately using a method called luminance building. So what they do is, when an AI generates a part of the image, you might want to put that back into a larger frame, like restoring a cropped part. That's where the uncrop function comes in. It places your smaller image into a larger frame. It's like adding a logo or a sticker or in painting certain areas. That's handled by the overlay function down here. So it pastes those extra graphics neatly on top of your base image. Then we have the mask creation and in painting function. Now if you want to use AI for in painting, basically fixing or replacing parts of an image, you need a mask. The mask creation function extracts a black and white image showing which parts should be kept and which should be replaced. If the image has an alpha channel, meaning transparency info, it uses that. If not, it converts the image to grayscale and uses it as a mask. Simple but super useful in editing workflows. Then we have this function which is conditioning of a text to image and inpainting. Finally, before generating an image, the model needs to be told how to condition itself or the type of job you are asking it to do. This is called conditioning. There are different types. From text to image generation, it creates a dummy image like a placeholder and fills it within the neutral value of preparation the AI. Second is inpainting. It prepares a special masked image with areas marked to fill the AI. And third one is the unclip model. The unclip model is where a special type of text or images are creating a different kind of zero value tensor to get the things ready. So basically these all things are required for you to create a stable diffusion model that could generate an image for you, fixes your color, manages the image size, paste extra layer if needed, and prepares a mask if required. Okay, and these are all the values you need to pass over to the model which one requires to create the image. You can take or read about these values from the stable diffusion documents and or copy these values directly from here, because the default image generation always remains the same. So But if you want to go advanced and want to tweak values according to you, you need to change these values. Other than that, you don't need to touch these values that you are going to pass into the model, and then everything's fine. Your model of stable diffusion will be built, and you would be able to create text from image. I would like to show you an example of how it looks like and how it gets created. So here you write the prompt, and on the right hand side the image gets created. You can tweak the values according to you, which goes in like an advanced version of that, where you change the GFG scale, the height of the image, the width of the image, and sampling steps, and etc. So this was the first method. Second method is very simple, very clean, and anyone can do that. Yes, anyone can do that. So I will show you that second process. What is that second process? Okay, so yeah, this is the only thing you need to do. Only 18 lines of code you need to write to create a text to generate text to image model. Yes. So what it does, I'll tell you. First of all, it imports a diffuser from this stable diffuser pipeline. Stable diffusion has a model on Hugging Face. Hugging Face is a, you can say, as a platform like GitHub that stores all the AI models. It has all the data science projects, all the AI models, including the pipelines to get that model. So for example, your computer cannot handle such large image training, or your computer isn't compatible with training such models that require high amount of computation power and GPUs. So what one does is that already the big companies, the big giants, they create model and they post it over there. So you just take those APIs, build a pipeline and use it over here. So that's what we have done it here also. Then we create a variable called pipe. We set up a stable diffusion pipeline from pre-trained. See, names are literally according to what we are doing. Stable diffusion pipeline has been called from the model. Then we dot is dot from using that, since it's a class, we need to use that object. So dot from pre-trained model. We are running that on the torch float 16, and if CUDA is available, CUDA is basically your provided by the graphics GPU provided by the NVIDIA. CUDA is built by NVIDIA, those libraries which help you run the model over to the GPU rather than the CPU. So this is it. If I have made a condition over here that if the laptop or the computer that is running this script has a GPU, will run the code over to the GPU. That would help the code run faster and build the model and create and or generate the image faster. And then we'll go over here, we pass it to the pipeline, we pass the CUDA to the pipeline, and the most important part, we write the prompt. This is the prompt, a fantasy landscape trending or artisan. This prompt is then passed to the pipe, which is here, which we created. The pipe is reads this prompt, okay, and then dot image 0. This image 0 is basically an array that tells the image function that you have to create only one image. So since you know array starts from 0 index, so yes, this creates an image that and only single image has been created by this function. And then simply we save this image and we print that image, that the name of this image, and the image has been saved successfully. So you will run this image, you will find out all these outputs, all these loadings. So basically the model is being loaded over here in the terminal, and then all the configuration and the settings that has been set by the model, all the pre-trainers. So model gets loaded over here, and finally we get our computed answer, which is this is the image that we have generated just now from this code. So I know the second method was really easy, very simple, everyone can implement it, and that was the entire goal of Hugging Face, to create these things in the first place, that anyone can create and use those AI models. So thank you.